Hello, everyone. What I want to do is go over homework one. The scores were mostly pretty good. A few people didn't do so well, so it's worthwhile to go over everything here. I'll try to be a little quick for some of these. Okay, so you initially, or Alicia initially invests 5,000. We have a monthly interest rate of 0.25% for the first 6 months, 0.5% for the next year, and 0.75% for the next 6 months. So the key here is that these are monthly interest rates. How much does Alicia have after 2 years? And find the equivalent effective annual interest rate for this 2-year period. All right, so we're given a 0 is 5,000. So I put 5. So A of 2 after 2 years. Okay. So 5,000 is going to accrue, well, 6 months of interest at 0.25%. So you take 0.25 and divide by 100 and add 1, it's 1.0025. So it's 6 times 6 months. This amount is itself going to accrue, and I'll generally not do this. I'll just do it for this one time to emphasize this, and I'll erase. But this is going to accrue 0.5% each month of interest. It's going to be 0.5% interest each month for the next year. So it's the next 12 months. Again, it's 0.5 over 100 plus 1. So it's 0.005 to the 12th. And this amount is itself going to accrue another 6 months of interest at 0.75%. So 1.0075 meter. That's not much better, but it's 1.0075. I think I'll have to make this a little thinner. All right, so that's going to equal 5,635 and roughly 59 cents. So I have to do a calculation with this in a second. So I will write to the nearest 6th decimal. Now, of course, I would do is just, as I do in other videos, don't bother with all these brackets. That's just kind of annoying. So you multiply these 3 together. Right. Okay, so for the equivalent effective annual interest rate, I'm pretty sure I mentioned this in the video, but EEAIR means equivalent effective annual interest rate. It's just a very useful little acronym for that. Right. So all we do is remember what the whole point is. It's like we have this annual interest rate I, this hypothetical annual interest rate I, where if I dump in 5,000 into a bank account earning I times 100% per year, I'm going to get back what I actually get back from this investment. So it's a one single yearly growth rate describing how this account grows. Now, this account grows for 2 years by I times 100% per year. What is that I? Well, just solve for I, divide by 5,000, take square root, subtract 1. It's roughly going to be 6.167%. 0.0616. So not much to that. And we'll do this a gazillion times in this course because it's just such a useful concept, the equivalent effective annual interest rate. Okay, so number two, I'm not going to do the way I say in video is not good. It's just you're gonna screw it up. I'm not sure if anyone did it the wrong way and got it right. There's just so much room to screw things up. So I do not suggest doing it. And if you do it and you get it wrong, I'm not going to spend too much time carefully checking where you made the mistake because it's just not worth it's a bad way to do it, and so anyway. Whatever you do, certainly draw the time diagram. And as we'll see in this later in this course, when we do annuities, time diagrams are absolutely your friend, even on exam FM. They do not take that much time to draw, and they just make your life so much easier, and you can preserve your sanity much better if you do that and get the problems right on exam FM. So initial investment of 5,000. So here's 5,000. At the end of the first year, another 5,000 is what you invest. All right. So I guess I'll do this once, kind of like I do in the video, and in the future I'll just. So what I'll do in the future is the following. So we just got a 5,000 investment at the end of the first year. At the end of the third and fourth year, you withdraw X. And then you have a penalty of 1%. So that means it's subtracting 0.01x. That's 1% of X. Okay. And you have 10,000 at the very end. Right? So this is what I'll do in the future. But I'll actually kind of do it like I did in the video. So my first 5,000, we're going to ask the question, what does it do at the end? Or what does it accrue to after 5 years? Well, interest is 7%. So this accrues to 5,000, 1.07 to the fifth. And if you don't need to do this, by all means, don't do it. It's a waste of time. But if you still want to do it like this, by all means, do it. I practically do this in my head, this kind of thing that I'm doing. All right, so this 5,000 accrues 1, 2, 3, 4 years of interest. Uh, 1.07, it's a little late here, so I make silly mistakes. All right, and we have at the end of the third year, well, it's minus X, minus 0.01x, and that's just going to be minus 1.01x. So just so that this doesn't get too crowded, I'm just going to write minus 1.01x. And this is going to accrue remember, the way we have to do this is withdrawals accrue interest, because if we did not withdraw that money, then that money in the real literal sense would have accrued interest. So it accrues, this is at t equals 3. So 3 to 4, 4 to 5, 2 years of interest. And this one here, minus 1.01x, accrues just 1 year of interest from 4 to 5. So add all these up, we get 10,000. I'll do this quickly. If you want to do it the bad way and you're sure you got it right, by all means, but there's just so much room for error. So I do not suggest it. It makes grading it so much harder. So I really don't suggest it. All right, solve for x. Round to the nearest penny. 1,594 and 39 cents. Okay, easy problem. Here's the growth rates for each period. Find the equivalent effective annual interest rate, the 5-year period, and the 3-year period, 2010 2014 and 2010 to 2012, respectively. Right. So we'll see what $1 grows to in both periods, and then just set up the equation for the equivalent effective annual interest rate. You can use any amount of money you want initially. $1, I guess, is the simplest. So for 2010 to 2014, what does $1 do? Well, we grow by 3% in the first year. We grow by 5% in the second year. So just doing like I did in the videos. 2% in the third year. We lose 1% in the fourth year, and we grow by 1% in the fifth year. So this is really, if it helps, 1 plus, kind of annoying to do this, but if it helps, this is 1 plus 0.05. One plus 0.02, et cetera, et cetera. So it's sort of like 1 plus minus 0.01, because we're decreasing by 1% in the fourth year. Okay, so this is simply going to be equal to 1.10302. So $1 roughly grows to $1.10. So we set up the equation for the equivalent effective annual interest rate. So again, it's like we're investing this dollar into this hypothetical bank account, earning I times 100% per year. And if we get back exactly what the investment gives us after 5 years, what is that I? Or in other words, in this account, money grows by I times 100% per year for 5 years. What is that I? That I is roughly 2%, 1.98%. And if you want to put your answer as a percentage, that's fine, no problem. All right, so same thing, go a little quicker. 2010, 2012. So 3% growth in the first year, 5% growth in the second year, 2% growth in the third year. It's actually a little bit more than 5-year growth. $1 grows to $1.10. $1.0313. So the 3-year equivalent effective annual interest rate, and same idea, money grows by I times 100% per year for 3 years. What is that I? It's roughly 3.3%. Right. So yeah, pretty easy problem. Okay, so yeah, one of these mixed compound simple interest problems. You invest 75,000 into account. You withdraw the funds when it reaches 125,000. For full years, you have 3% compound interest, but for fractions of years, you have 4% simple interest. How long does it take for the fund to be withdrawn? So do this like we did in the video, just simply set it up, 75,000. 1.03. The N is 125,000. Plop this into your calculator. So particular ln both sides, or sorry, divide by 75,000 first. Probably the easiest thing to do. And then ln both sides. Ultimately, you'll get n is ln 125,000 75,000 over ln 1.03, roughly 17.28. So we're going to use n equals 17. So we have 17 full years. Oops. And you can check if you do it for 18 years, you're going to get more than 125,000. So just kind of curious. Let me just check that. 75,000 times 1.03, better be over it. A little embarrassing. Yeah, you get quite a bit more than quite a bit more than 125,000. Okay. Right. And if you did 16, you would get something more than a year, I believe. Pretty sure. Yeah, if you did n equals 16, you'll get the answer S is something bigger than 1. Right. Right. All right, so this is going to be equal to what? 123,963,5724. Okay, so this amount earns simple interest. 1 plus 0.04s, where s is how much into the 17th year we're at. So this is 125,000. So solve for s, 0.2092. The answer is just simply total 17.20902 years. All right, and last but not least, so yeah, these are a little annoying, but they're not too bad. Joe deposits 100 now and 100 in 10 years into a fund earning 10% simple interest. Okay. So here's Joe. Right, so we have 100, t equals 10, 100 now. That's 15. Okay, yeah, so we can just simply get, let's say A is how much is in Joe's account after 15 years. So the 100 earns 15 years of simple interest at 10%. And this 100 here earns 10 to 15 is 5. So even here, it's useful, I think, to It doesn't hurt to draw a time diagram. But for the first initial one, it's the full 15 years. For a total of 400. All right, so there's Tina. So it's 100 N and another 102 N years. So we have N. Right. Okay, so here's 100. Here's 100. All right. So from here to here, well, here to here is N. So this has to be 15 minus N to get a total of, well, total of 15. Right. And I should probably do it up here, but from here to here, well, from here to here is going to be, well, of course, 2N. So this has to be 15 minus 2N years, right? Let's say B is the accumulated value of Tina. So B of 15 is going to be 100. It's at 9%. So the first 100 rather earns 15.9 years of interest. Yeah, earns 15 minus N years of interest. I even said a second ago, but it earns 15 minus N years of interest from here to here. Second one earns 15 minus 2N years of interest from here to here. There. So plus 100, 1.09, 15 minus 2N. Easiest thing to do is factor out 100, 1.09 to the 15th. So now it's 1.09 minus N plus 1.09 to the minus 2N. Minus 2N is the same thing as 1.09 squared. So set this to be X. 100. 1.09 to the 15. X plus X squared. So, what does that mean? 400 equals 100. 1.09 to the 15. Now we divide by this whole thing and then use quadratic formula. So what does that mean? That means just repeating myself here, this is what X is, but solving this quadratic here, you're going to get X is 0.6611. We throw out the negative solution. Room. Okay, so solve for N. So take this here, solve for N. N is 4.8023. So hopefully that was useful. And yeah, I'll do this for each one. All right, so long, take care, bye-bye.